ಈಗ ಅದು ಬಂದಿದೆ OBS ನಲ್ಲಿ. ಅದು ಸ್ಟಾಪ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಅಂತ ನಾವು ಕೊಡುತ್ತಾನು ಅದು ಇದೇ ಇರುತ್ತಲ್ವಾ, ರನ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ವಾ? ಅಷ್ಟಾದ್ರೆ ಸಾಕಲ್ವಾ? ನಂಗೆ ನನ್ಗೆ ಗೊತ್ತೇ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ನಾನು ಕಾಣಿಸ್ತಾ ಇರಲ್ಲಲ್ವಾ ಇಲ್ಲಿ, ಅದಕ್ಕೆ ಕೇಳ್ತಾ ಇರೋದಷ್ಟೇ. ಹೌದಾ, ಗೊತ್ತಾಗುತ್ತಲ್ವಾ? ಓಕೆ ಫೈನ್. ಓಕೆ ಓಕೆ ಓಕೆ. So, hello everyone. Welcome for the today's session that is on heat at work. In this session, we'll be discussing about what is a main difference between heat and the work, how to understand the concepts of heat and work. So these are the course objectives for today's session. Yeah. So the course objectives for today's session is to describe the behavior of the system in terms of properties and processes, to understand the path function and state function, to understand the concept of heat and work, and to know the difference between them, and how to apply these things in the applied thermodynamics or the other processes or other thermodynamic processes. So after completing this course, one should be able to define and describe the properties and processes used in the thermodynamic analysis to convert heat into work and work into heat, the governing laws to apply control volume analysis. Yes. Now coming to what is heat and what is a work, defining heat and work. How can you define what is a heat and what is a work here? So whenever we talk about this, we have our initially whenever we ask what is heat, we have that pre-mindset of saying that heat is a form of energy. We commonly we say it as what? Heat is a form of energy. We say this. Yes or no? By our practice, we say that always used to say that heat is a form of energy. But whenever we say that, is our definition is correct? Like our definition is like heat is a form of energy is a correct definition for us. So for that reason, here I am giving you the clear idea what do you mean by heat. So what is work? Whenever we say work, we say that it is a force dot displacement. Force, actually it is a dot product, it's not a cross product, so you avoiding this is a dot product. What is work? How you give the work? You give it as Fs cos theta. You give the work as Fs cos theta. So in mechanics or in your common in our things, we say that W equal to Fs cos theta. W equal to Fs cos theta, we say. So So define what we define mechanically. We define uh, okay. Sorry, I think this is the first class I am using, and I don't know whether who has joined or not. Just give a second. Okay, so mechanical work is defined as force into displacement Fs cos theta. For example, let us say how we define the mechanical work is, let us say if there is a block over here, and if you are pushing this block with F and it moves a distance S, then we say if it is, since the distance, this is theta is what, uh, between them the theta is 0 degree, so theta equal to 0, therefore we get W equal to Fs. But if it is like moving on an inclined plane at an angle of 60 degree, and this is some weight and it has to move some distance, yes, then we take this as Fs cos theta. This is the common practice of work done in case uh, what uh, what in mechanical work. This is called as mechanical work. What is thermodynamic work? So a thermodynamic work is defined as a rising or lowering of pulley due to the change in the system. Before going to heat and work, we should understand what is a system and what is a surrounding. System and surroundings. So for example, let us say the system is defined as anything on which the concentration of steady is made. So anything on where the concentration of steady is made. Concentration of steady is made is called as a system, and leaving that anything outside to this is called as the surroundings. This is the surroundings, this is the system, this is the surroundings. So we should know here what is a system and what is a surrounding. Next, coming to, whenever we say the work, what is the what SI unit of work? It is the joules. So work can be, there are many types of work: expansion work, electrical work, magnetic work, etc. So to understand that, let us say, I'll just do the things over here only. Let us say what is expansion work? Expansion work here, or we say this, sometimes we say this as free expansion also. We say this as free expansion. So what is this free expansion? So let us say there is one chamber where we kept the gas molecules to the one side. These are the gas molecules. Here there is vacant. It is vacant here. And this both sections are separated by a cover or by a plate. both distance are separated by a plate. Okay, so if this is now, when I remove this plate, by removing this plate, what happens? This all the gas particles start going into this thing, or they start moving into the vacant section. This is why this happens. This happens because it is the properties of the gases to expand. So this is also can be considered as the work. Can be considered, this is also a type of work. We call it as free expansion, and this is also called as, sometimes we call this as, since this is a property of the gas, it is also called as diffusion. So what is this diffusion here? The diffusion is the movement of gas molecules from a region of higher concentration to a region of lower concentration. That is what we say it as a free expansion. And one more thing, yeah, and that is called as free expansion. What is electrical work? So let us say there is a load which is connected to the battery. Velocity, what potential difference V, resistance R, current is flowing I. Now, what is this? What electrical work? So let us say instead of this resistance, I will connect this to the. I will connect this to the. So let us say there is a conductor, okay, which is connected to the battery. So when you apply the voltage over here, or the potential difference across this conductor, the electron which is there over here, it starts making a movement to this. It starts making movement to this. So what happens here? There is a displacement of a mass from one end to the other end. So what is this? Nothing but, this is nothing but the work is being done by the electron for a moment of one one part to the other part when you apply some external source. So this is called as the electrical work. So like this, there are many kinds of work which we are going to discuss over here. So now coming to what is thermodynamic work then? What is thermodynamic work? So what is this thermodynamic work is? So let us consider. So let us consider there is some liquid over here and you are supplying some amount of heat to this liquid. So what happens, or this becomes, if it is this is complicated, let us take a cooker, pressure cooker. So there is something here that is called as vessel. Okay, so what is thermodynamic work? I say the thermodynamic work is that work which is nothing which is defined as raising or lowering of the vessel. Sorry, vessel, not vessel, it is vessel, sorry, vessel. Okay, what I say the thermodynamic work as raising or lowering of vessel of a pressure cooker. So that means what? This pressure cooker which we are talking about, the vessel of that pressure cooker will raise up or fall down because the change in the system here. What is the change inside the system? The change inside the system, that is increase in volume or decrease in volume, or increase in pressure, increase in pressure of the gas or decrease in the pressure of gas. Due to this, what happens? The vessel what raises up or falls down as a result of this. This is what we call it as the what thermodynamic work. This is called as a thermodynamic work here. That is, due to change in the pressure and volume, the vessel rises up or falls down. That is called as the thermodynamic work. Okay. So after coming to the work, after understanding what is thermodynamic work, we understood that thermodynamic work is the function of pressure and volume. So if we have to say that thermodynamic work is being done, then there should be the change in pressure and volume. If there is no change in pressure and volume, we cannot say that there is a thermodynamic work can be done. So we can say that thermodynamic work is a function of pressure and volume. It is a function of pressure and volume. So that is what the thermodynamic work is all about. Now coming to what is heat and what it can be defined as. Heat is defined as the transfer of energy as a result of temperature difference. So as we say that work is a function of pressure and volume, we say that heat is a function of system. Heat is a function of temperature. So as there is increase and decrease, if there is a change in temperature, then there is the heat will result, heat will change. So we say that heat will flow, and unless heat will flow if there is a change, if there is a temperature difference. So heat always flow from a higher temperature to the lower temperature. Okay. So heat transfer occurs if there is if there is temperature difference. That is the first point here. The transfer of energy as a result of temperature difference is called as heat. In thermodynamics, heat is not an entity or a form of energy. This is very, very important over here, guys. Heat is not an entity or even a form of energy. So till now we are saying that heat is a form of energy, heat is a form of energy. Now I am saying that heat is not a form of energy. It is only the mode of transfer of energy. You should know this, that heat is not an entity of a system or even a form of energy. It is a mode of transfer of energy. So what do you mean by this? How can we elaborate this? Just give me a second here. Yeah. So we say that, what do you mean by this? In thermodynamics, heat is not an entity or even a form of energy. We don't say that in thermodynamics. What is heat then? Heat is a mode of transfer of energy which occurs because due to the change in temperature. Due to the difference in temperature, the flow of energy occurs, that flow of energy is called, that energy is called as heat here. So what do you mean by what do you mean by this? For example, let us say there is a let us say there is a what tumbler in which there is the boiling water. The water is kept for boiling. So now when the water is kept for boiling, so what is happening here? Actually from the burner heat is getting transferred to this. Now what we say, after some time we say that it is hot. So and we presume that when we are saying hot, that means it contains heat. It is not, but it doesn't happen in thermodynamics. If it is hot, that doesn't mean it contains heat in it. Because we are saying here very clearly that heat cannot be stored or heat cannot be occupied inside the body, and hence we cannot say that heat is a entity of a system. Therefore we say that heat is not an entity of a system. Heat cannot be the part of a system. Heat comes and goes. It cannot be stored inside the body. The one which gets stored inside the body, that is not the heat. It is called as internal energy. Just give me a second. Sorry for the disturbance. Yeah. Yeah, heat is heat is a mode of transfer of energy. Heat is not the entity of a system. Heat is transfer of energy by virtue of temperature difference. I already told that after if there is the temperature difference, then only there is the heat transfer. Heat is the name of a process, not the name of an entity. Body contains internal energy and not heat. That only I suggested over here. So these are the important things which you have to make a note of it. Okay. Yeah. So next, work is coordinated flow of matter. Lowering of a weight can do work. Motion of a piston can do work. Flow of electrons in conductor. These things we have seen that electrical work, then what shaft work. There are different kinds of work which we have gone through. Now heat involves random motion of matter, like gas molecules in a gas cylinder, water molecules in a cup of water, atoms vibrating in a block of copper. All these are what constitutes the heat. Energy may enter the system as heat or work. Basically we say that heat and work both are the we say that heat and work both are the modes of transfers of energy. Neither heat can be contained inside the body nor the work. Both we cannot store. We can only, heat will come, heat work will go, or work will come and it will go in the form of a heat. So basically both heat and work are the modes of transfers of energy for thermodynamics, or in thermodynamics heat and work are the modes of transfers of energy. Energy may enter the system as heat or work. Once inside the system, it does not matter. This is also very important point here. Just a second. This is also an important. So once inside the system, it does not matter how the energy entered the system. Okay, it does not matter how the energy entered the system. Work and heat are terms associated with the surroundings, and once inside the system, there is no memory of how the input was received. The energy is stored as potential energy and kinetic energy. This energy can be withdrawn as work or heat from the system. Now I am showing here some of the different types of work. W is positive if work is done by the system, and it is negative if work is done on the system. These are conventions. Sometimes it can be work we can take accordingly, but commonly we practice that work done by the system is positive and work done by this on the system is negative. So work if we say positive, that means work done on the system or work done by this. What do you mean by this? For example, let us say what do you mean by work done by the system and work done on the system? Let us say there is a cylinder and a piston arrangement. Cylinder and piston arrangement. Now, if I compress this using some force, then we say that work is done on the system, and we consider it to be negative. Now, if in case this gas, what is there, due to high pressure, it pushes the piston in this backward direction, applying the pressure, then we say work is done by the system, and we consider work as to be positive. So these are some convenience of what we can say here. So what is work done by the system and what is work done on the system? Okay. Yeah, how we get work done? Relationship between heat and work. So pressure is given by what? Force. Work is given by force into displacement. Pressure equal to force by area. So force equal to pressure into area. So volume equal to length into width into height, or area into D. So D equal to what? V by A. So work can be given by, instead of taking F, I can write it as P into A, and instead of D we can write it as V by A. A goes off. So the work is nothing but pressure into volume. Yes. Now coming to the important topic called as internal energy. So always we have five things or three things basically. One is heat. Yeah, let us say heat, internal energy, enthalpy, latent heat, and specific heat, let us say. So here all these five are little confusing. What is heat, what is internal energy, what is enthalpy, what is latent heat, what is specific heat? All these are like, it looks like what is this heat and heat again and again and again. What is these things? So I'm clarifying you the things over here. As I already said that there is nothing as such which is heat which can be stored inside the body. So here the confusion, very clearly I am saying that heat is not a form of energy or entity of the system. It is just what we say, it is a mode of transfer of energy. It is just mode of transfer of energy. Nothing is there like it cannot be stored inside the body or as such. We cannot do that. It is just the mode of transfer of energy. What is internal energy then? Internal energy is something which can be stored inside the body, or mathematically we say that the difference between the heat and work is called as internal energy, we say that. Okay, that let's come to the, that is the second part of that is the next part where we talk about the first law. So let's not mix it with here. So what is internal energy? That I can answer it using the spring ball model. What is this spring and ball model? So for example, let us say this is a spring and ball model over here. Now when I pull this what this ball, what happens? The springs get extended, and when it get extended, what happens? The springs what it will get extra, the spring force get extended and make all the other to be in the system, and only it allows that ball to go to that extent. So here the spring and ball, what it shows here is the spring acts like the internal energy over here, where it balances that whatever it is going, it is balancing, the spring is balancing basically the ball and the other balls not to get displaced by the displacement of one ball. If one ball is getting displaced, it is not allowing the other balls to get displaced. What these two springs will do here, the two springs will get expanded and support that ball which is trying to get extended, and again it brings back to its position when that force is removed. So here the internal energy is that energy which is stored inside the body due to the change in heat and work. So that is what the internal energy we can say here. So it is the total of kinetic energy due to the motion of molecules. It might be translational, rotational and vibrational, and potential energy associated with the vibrational and electrical energy of atoms within the molecules or a crystal. So we can say that internal energy is given by mc v delta t. This I will come back again. What is this? Okay, and work is given by F equal to P delta V. Now coming to work, heat and internal energy at molecular level. What do you mean by work? What do you mean by heat? And what do you mean by what? Just give me a second. Work, heat and internal energy at molecular level. What is work, what is heat and what is internal energy? So transfer of energy that makes use of uniform motion of atoms in the surroundings. So that is called as work. What is heat then? Transfer of energy that makes use of random motion of atoms in the surroundings. So here work is nothing but transfer of energy that makes the use of uniform motion of atoms in the surroundings. Transfer of energy that makes the use of random motion of atoms in the surroundings. What is internal energy? Kinetic energy plus potential energy of the system systems constituent atoms. What is work then? It is a transfer of energy that makes the use of uniform motion of atoms in the surroundings. What is heat then? Transfer of energy that makes use of random motion of atoms in the surroundings. And what is internal energy? Interkinetic energy plus potential energy of the system constitute atoms. That is called as internal energy. So these things I think you have understood. I have defined you. I will just go through again what are the things. Just have a look at the points. What is heat? What is work? What is the different types of heat and work? Work done is positive, work done is negative. Relationship between work, internal energy. Yeah, so we'll do some problems on heat and work over here. So let us say the properties of a closed system change following the relation between the properties I'll do the problems over here only. I'm thinking like some problem is there with the PPT, I guess. Okay, so just see this one. The properties the properties of a closed system change according to PV equal to 3. Calculate the work done when the pressure increases from calculate the work done when pressure increases from from 1.5 bar to 7.5 bar. Okay, so how can we get it? PV equal to 3. Calculate the work done when the pressure is increases from okay, so they had given that PV equal to 3. So we can say that P1 V1 equal to P2 V2 equal to 3. So they had given that P1 equal to 1.5 bar and P2 is equals to 7.5 bar. Yes, so P1 V1 equal to P2 V2. So V1 will be equal to 3 by P1, that is equal to 3 by 1.5, that is equal to 2 meter cube, and V2 is equal to 3 by P2, that is 3 by 7.5, that is equal to 0.4 meter cube. So now work done, W is given by work is given by work is given by 100 integration of 1 to 2 P dV. So that is equal to 100 integration of 1 to 2 3 by V dV. So that is equal to 300 1 to 2 1 by V dV. So that is equal to 300 log V2 by V1. So 300 log 0.4 by 0.2. That is work done is equal to minus 483 kilojoules. So that is the thing here. Work done by the system. We'll do one more problem over here. Okay. To a closed system, 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 to a closed closed system, 150 kilojoules of work is supplied. Okay. If the initial volume is 0.7 cube, if the initial volume is 0.6 meter cube and pressure of the system changes as P equal to 8 minus 4V, determine final volume and pressure of the system. Final volume and pressure of the system. Determine to a closed system 150 kilojoules of work is supplied if the initial volume final volume and pressure of the system. Try to do this problem quickly. Yeah, go through this problem quickly. To a closed system, 150 kilojoules of heat is supplied. That means work is negative here. If the initial volume is 0.6 meter cube and P equal to 8 minus 4V, determine the final volume and pressure of the system. Okay, so let's start solve this problem. Okay, so they had given that W is equals to minus 150 kilojoules, V1 equal to 0.6 meter cube, and P is equal to 8 minus 4 V. V2 equal to question mark and P2 equal to question mark. So work done, W is given by 122 PdV. PdV. So that is equal to 100, 122 100, 122. P is what? 8 minus 4 V into dV. So if you integrate this, you will get it as 100 8V minus 4V square by 2 1 to 2. So this becomes equal to 8 V2 minus V1 minus 4 V2 square minus V1 square all divided by 2 into 100. So that becomes equal to minus 150 equal to 100 into 8 V2 minus 0.6 minus 2 V2 square minus 0.6 square. So that is equal to 2 V2 square minus 8 V2 plus 2.58 equal to 0. So use the quadratic equation thing here. You will get V2 to be equal to 0.35 meter cube. Okay. And what will be the final pressure? P2 is equal to 8 minus 4 V2. So that is equal to 8 minus 4 into 0.35. That is equal to 6.58 bar. So this is the solution for this. What is, I'll just show you the question one more time. To a closed system, 150 kilojoules of work is supplied if the initial volume is 0.6 meter cube and pressure of the system changes as P equal to 8 minus 4V. Determine the final volume and pressure of the system. What is the final volume of the system and what is the final pressure of the system? This is the question which has been asked here. So for that, the solution is, so the given thing W equal to Y minus here because work is supplied to the system. So W equal to minus 150 kilojoules, V1 equal to 0.6 meter cube, P equal to 8 minus 4V, V2 is question mark, P2 is question mark. So same way, we start with W equal to integration of 1 to 2 P dV. So why this 100 here? Because work is in terms of 150 kilojoules. So for that reason, kilo, instead of writing that, we are writing it as 100. So 100 is to 1, integration 1 is to 1 to 2, 8 minus 4V, 8V minus 4, integrate it, you will get 8V minus 4V square by 2. So this is what 8 V2 minus V1 minus 4 V2 square minus V1 square by 2 into 100. So if you solve this, you will get this as 2V2 square minus 8V2 plus 2.58. This becomes a quadratic equation. Use that formula minus B plus or minus root of B square minus 4AC divided by 2A. Use that and you will get the V2 to be equal to 0.35 meter cube. Then you substitute in the given equation. You will get 8 minus 4 to V. So these are the things for the today's session. Just have a look at it. What are the things? Defining the heat and work. Then what is work? So yes, so these are some of the problems, some of the things for the today's session. Hope that you have understood that session today. Okay, so yeah, so yeah, so this is it for the today's session. So here I am Professor Ramachandra Kulkarni signing off for the session. I'll meet you in the next session. Huh? Hello. Last one. Okay, so sorry. Yeah, let's get this.